So good morning, everybody. We will do now the first exercise in the midterm. So we want to evaluate 5 plus 5i to the 3 minus 2i. And here we notice that since the exponent is not an integer, this will be actually not just one number, but a set of numbers. Why is that so? Because we will use the following fact that if we have z and w complex number, and I want to compute z to the w, then this is the same as the exponential of the logarithm of z to the w. And now I use the property of the logarithm, w comes in front, and we get exp of w times the logarithm of z. So now we have to see what is the logarithm of z, and this is a complex number, whose real part is just the logarithm of the norm of z, and the imaginary part is the argument of z plus 2k I, where k is an integer and arg is the argument. So this is a map that goes from C to minus pi to pi, and gives me back the angle. In our case, what is z on this w? So in our case, z is equal to 5 plus 5i, and w is 3 minus 2i. So in order to apply this formula over here, we need now to compute the norm of z and the argument of z. So let's see this in a picture. So if here is the origin, then we go 5 units to the right, maybe here, 5 units above, and then this is my number z. So we see here that the norm of z is equal to 5 times square root of 2. And the argument of z is basically this angle, and this is half of the right angle, so it's pi over 4. Now we can substitute in the main formula, and we find that 5 plus 5i to the 3 minus 2i. This is the exponential of 3 minus 2i times the logarithm of 5 plus 5i. This is again 3 minus 2i times the logarithm of the norm of z plus pi over 4 plus 2k pi times I. Okay, so now we have just to expand this product here. We get 4 terms. So we get 3 times the logarithm of 5 square root of 2 plus 3 times pi over 4 plus 2k pi I. Then we get minus 2i logarithm 5 square root of 2. And the last term is minus 2i pi over 4 plus 2k pi I. Okay, so let's put the real imaginary part together. So the real part is given by the first and the last term because we have I times I equal to -1. So the real part is 3 logarithm of 5 square root of 2. And then we got here plus 2 pi over 4 plus 2k pi. And then we get the imaginary part. This is 3 pi over 4 plus 6k pi minus 2 logarithm of 5 square root of 2 I. And now what we can do is use the property of the exponential in order to write this number in polar form. So we have the exponential of the real part times the exponential of the imaginary part, which we can write as cosinus of 3 pi over 4 plus 6k pi minus 2 logarithm 5 square root of 2 plus sinus of the same thing. Right. And now we notice here that cosinus and sinus are periodic of period 2 pi. So these two can go away. And we get exponential you're right, of 3 logarithm 5 square root of 2 plus, here maybe we can already expand this, pi over 2 plus 4k pi. And here comes now okay, so this is the end result. So you see that yes, k varies, we get many numbers. If you want to have an idea of where this number lie on the complex plane, you can do maybe as follows. So you use once again the property of the exponential here. And we can write this number as some z0 times e to the 4 pi to the k, where this 4 pi to the k comes from this part here. And what is z0? So z0 is just a complex number with a norm exp of 3 log 5 square root of 2 plus pi over 2. And the polar part is cosinus 3 pi over 4 minus 2 square root of 2. So if you want to represent z0 on the plane, you see that this angle here is roughly minus pi, a bit bigger than minus pi. So if here is the origin, then if you compute also the norm, then you will be somewhere here. This is your z0. which is also z0 to the e to the 4 pi to the 0. And then all the other numbers will lie on the half line starting from the origin and passing through z0. So you will also have here all the other numbers on this side for k negative. So here, for example, you will have z0 times e to the 4 pi to the minus 1, and so on. And then on this other side, you will have for k positive. So here it's not really scale correct this, but just to have an idea. And then all the other numbers for k positive will go on this other side. Okay, so that's all for the first exercise.